problem 18 was similar to problem 17. So if you didn't watch the video for problem 17, you might want to. The idea is there's a lot of stuff happening step by step in this method, but there's a simpler way of thinking about what effect all of this has on the variable n. And so the question was testing, are you able to like code trace it and then figure out how to express this in a simpler way? So let's try. You could either do it with a single example of an input, or you could try and think about it kind of more commonsensically, logically. Let's do it with an example. So let's say n is, I don't know, 3. What's going to happen? So this is going to loop. Let's see, I goes from 3. I goes from 0 up to 2. So if you think about it, 0, 1, 2. So it's going to loop 3 times. And each time in the loop, n gets replaced with n plus n. So let's do it. Here, I'm going to notate it this way so we can keep track of what happens every single loop. So n starts out at 3. After the first loop, 3 plus 3 is 6. So n will be 6 after the first loop. And then after the next loop, 6 plus 6 is 12. And then after the next loop, 12 plus 12 is 24, and then we return n. So what did we really do? 3 turned into 24. Maybe it's not obvious what that actually did, so let's do it with another example. Let's say n is 1, and let's do loop 1, 2, 3. So if n is 1, after the first loop, 1 plus 1 is 2. After the second loop, 2 plus 2 is 4. After the third loop, 4 plus 4 is 8. So how do you think about a single operation that will turn 1 into 8, but that will turn 3 into 24? And if you said all we're doing is multiplying by 8, uh-oh, the lights are going out. Okay, that would be right. So you could replace all of this just by saying return 8 times n. Okay, what's a different way of thinking about this? Instead of plugging in a number for n, let's think about it in general, just keeping n as n. Okay, so if n starts out as a value n, in the first loop we replace it with n plus n, which is 2n. So n gets replaced with 2n. Okay, in the next loop I'm taking 2n and I'm adding it to itself. So we have 2n plus another 2n becomes 4n. In the next loop, n has become 4n, so I'll have 4n plus 4n get saved, so that becomes 8n. And so then I return 8n in the end. So you could think about it in general that way as well. The overall thinking skill we're practicing is go step by step, but then step back and ask, what overall effect is this doing? Because simplifying, like simple code is easy to debug. It's easy to verify that it does what you think it does. So being able to take code that's a lot of steps and simplify it down often is the key to making your code less fragile, more readable, easier to think about. Okay, this question was about understanding the difference between sequential loops, where loop B only starts once loop A is completely done, and nested loops, where you have a loop inside a loop. So here you'll notice that the B loop starts at the line with 4 and ends at the closing brace, and it is entirely contained inside of the A loop. So these two, when they run, are doing very, very different things, and we want to make sure you know what that is. So the question was, how many times does star display? So on the left-hand side, it does exactly what it appears to do. A goes from 1 up to 3, and so that's 1, 2, 3 total loops. So here, the first loop when A equals 1, we display a star, and then A equals 2, we display a star. A equals 3, we display a star. A equals 4, we exit. So this loops 3 times. This one is the exact same conditions up here, just a different loop counter, different loop variable. So that's also 3. So this is going to display star 6 times. Okay, that one is normal. This one is the one that most students find to be more difficult. So here's what you have to realize. this outer loop only repeats when you get down to the closing brace. And this inner loop is going to do all of its repetitions before we ever do the second loop of the outer loop. So here's what's going to happen. A gets initialized to 1. We ask, is 1 less than 4? The answer is yes. And so now we're going to enter the second loop. So right now, A equals 1. We're tracing it right now. So A equals 1. And now as long as A equals 1, we're going to initialize B to 1. We ask, is B less than 4? The answer is yes. And so we display a star. So let's keep track of B. So B is 1 right now. We displayed star. Hold on, let's get a better pen. Okay, there we go. So A is still 1. B is 1. We display star. We get to the closing brace, and we loop back up to this for loop, and we add to B. So now B is 2, and we display a star. Then we go up here, and B is 3, and we display a star. Notice that the whole time that we're looping here, A is still equal to 1, because we need to finish all the repetitions of this loop before we get to that closing brace, which is when we add to A. So here's a great way of thinking about it. This for loop is repeating 3 times, and it's going to do that for each iteration of the outer loop. So when A is 1, this displays 3 stars. We get to the closing brace, and so now A is 2, and then we re-enter this loop starting with B equals 1, because it's like we're doing it for the first time. And so then we do 3 more loops here. We get to the closing brace. We add to A, so now A is 3. We re-enter this loop starting over with B equals 1, and we do 3 more loops. So if this repeats 3 times for each value of the outer loop, let's see, the outer loop has 3 values. The inner loop repeats 3 times. So if we're repeating 3 times for each of 3 outer loop repetitions, that's 9 times total. So this way of thinking, we're going to do it right away in Unit 1 because nested loops are super important for a lot of stuff. And so it's good to get this under your belt right away so that the actual content of the year is going to be less confusing. As a self-check, why don't you decide how many times does star display here? Pause the video. Okay, let's trace through the thinking on this one. My logic in coming up with this problem was I was trying to come up with something where you can't do a simple thing based on the last answer. So based on the last answer, you might think, oh, nested loops. I just multiply the number of repetitions times the number of repetitions. I want you to have to look at the entire code fragment and think what's happening overall here. So let's decide. The outer loop. How many times is the outer loop looping? I go from 1 up to 10. So that's going to loop 10 times. So let's say 10 times. This inner loop is going from 0 to 8. So let's see. 0, 1, 2, 3, 4, 5, 6, 7, 8 is actually 9 iterations. So this is looping 9 times. So it's true that this one in the middle, I'm repeating this star 9 times for each of the 10 loops of the outer loop. So that star is actually going to display 90 times. But I've got this other star here. This other star is not inside an inner loop. So this star is just going to display once for each iteration of the outer loop. So that's going to display 10 times. And so I add them up, and that's 100 stars total. So again, I want you to focus on flexibly being able to put together these ideas so you can think of new scenarios. Okay, let's do the last two. Question 20 is about what are valid ways of using this object. This is not an object, this is a class definition which defines what does it mean to be a certain kind of object. In this problem there were actually no correct answers. And I think some people freaked out and you assumed that there had to be one correct answer because I said write true if it is valid and false if it's not valid. I gave you things that were all not valid. But it's good to be able to recognize that. So a couple of things. What about this? Could I say thing dot yoho 9? So decide, is this valid, yes or no, and why? And hopefully you said no. It's good to check to see, does the input 9 match the input that yoho is expecting? And it does. But the problem is capital thing is not an object. Thing is the name of the class. It's the name of the data type. So we haven't actually made a thing yet. So instead of that, we would need to do something like this. Thing t equals new thing. And we give it some numbers. And then once you've actually created a variable that holds your object, then you can say t dot whatever. So that's okay. So that was the first thing that I was testing, is making sure that you realize this is the class declaration and that you have to run the constructor to make an object. And then once you have an object, the object can run the method. A different way of thinking about this is everything has two variables, an x and a y. And so yoho looks like it's changing the x and the y. If I just said, let's go back to the original one. If I just said thing.yoho, it's like what x and y are supposed to be getting modified here. We don't even have an x or a y yet because we never ran the constructor. A different way of thinking about it is, you know that a class, you're supposed to be able to use it to make lots of objects. So I could equally well have made several objects. I could have thing A is new thing, and thing B is new thing. And so in that case, if I'm going to say like thing.yoho, which things variables are supposed to be changing? I've got an x of 9 and a y of 2. I've got an x of 5 and a y of 7. So when I run yoho, like which set of things is supposed to be modified? And the answer is, the way that you know is which variable is actually running it. So if b is running yoho, I know that I'm going to be modifying the b variables. If a is running yoho, I'm going to be modifying the a variables. That's another reason why I think in one of my wrong answers I asked, could we just run yoho? And again, like the yoho method is supposed to be changing the attributes of a specific object. So you need to have, like, what is the actual object that's running the method? Okay, let's see what else went wrong here. Okay, what about this? I just changed this to be 5 and 7.0. This wouldn't be valid because 7.0 is not an integer. It is definitely a decimal number that's equivalent to an integer, that's equivalent to the integer 7, but this .0 means it's being treated like a double, and so you can't pass a double value into an integer variable here. So that was one of the issues. I think those two facts cover all of the wrong answers. So if all of that made sense and you feel happy, you will definitely get that one next time. Problem 21, I told you math.pow a comma b represents a to the power b. Math.square root k represents root k. So how would you write a single line of Java to compute root of p to the power p? Oh, the lights are going off again. How would I write a single line of Java to compute p to the root p? What about root p to the p? So this is about how do you nest things. So here I'm thinking I want to find the square root of something. So I'll say math.square root. What do I want to find the square root of? P to the power p. P to the power p is a call to math.pow. So as the input, I'll say math.pow p comma p. Okay, what about this one? So here, you might think order of operations, I want to find square root p first. But the problem is, if I do math.square root p first, it's like, you know, how am I going to get that to be the exponent of p to the power to something? So I want to start with the operation that's kind of the outside operation. So I want p to the power of something. Just like here, I said I want the square root of something, and then I didn't think about what I wanted the square root of. I did that later. Here, I'm like, I want p to the power of something. What's that something? I'm not going to think about it right now. I'm going to do that part in a second. So I'll do math.pow. Okay, the base is just p, but then the second input is the exponent. And that's where I want the square root. So then I could do math.square root p. Here it's sort of the reverse. It's like I want something to the something. So I'll do math.pow, something to the something. First input's the base, second input's the exponent. The exponent should just be p. The base is the thing where I want the root. So here I'll do math.square root p. So this problem was about, like, can you think about what composition of methods is going to make sense for computing the thing that you want to compute. Problem 22, I'm not going to do, but problem 22 was a for loop where I forget exactly what it looked like, but it was like int k equals something, and then like k is larger than something smaller, and then we were subtracting something every time. So let's subtract 6 every time. And then I had like a sum variable was something, and I was going to add into the sum, you know, some number relative to k, but then I had this if statement where like if sum is greater than something, then I'm going to set k equal to a value that would cause my loop to exit, like this. So it was code tracing like this, where you really did have to do kind of one thing at a time very, very carefully and realize that if k gets set to 10 here, then even if k was, here, let's make this something like really obvious. Let's make this like 101. So this is going to go wrong right away. Okay, let's trace it. So sum starts out as 100. K starts out at 27. So I say, okay, 27 minus 1 is 26. I'm going to add 26 into sum. So now sum is 126. Is sum larger than 101? The answer is yes, so I set k to be 10. Then here I subtract 6 from k, so now k is 4. Then I ask, is k larger than 13? And the answer is no, and so I exit. So that might not have seemed that complicated now, but the original problem, I think there were a lot of situations where, you know, maybe sum was exactly equal to 101, or maybe maybe it looked like this, like k was equal to 13, and you had to know to go through one more loop. So there were a lot of like little tiny places where you could go wrong if you weren't very, very careful in thinking step by step. Anyway, you'll get more practice with that kind of thing as the year goes on. It's not the most important programming skill, but it is nice. I think programmers do tend to have attention to detail when it matters.